Now let's talk about the three types of radiation that have wavelengths smaller than visible light. This is the high energy end of the electromagnetic spectrum. Sometimes these three are called ionizing radiation because of the effect they have on matter. Now, you need to understand that these three are a lot more serious than the ones that we spoke to before. All three have negative health consequences, but they are still useful in their own way, properly understood, and we can turn them to very great use. So here I have got a black light. It is a bulb which works like any other, but what it does is it gives off ultraviolet light. And to our eyes, we can see a small part of purple glow, but you need to understand that this is actually really bright in a colour that neither my eyes nor this camera can actually see. This here is producing a huge amount of ultraviolet light that fills this room, and the ultraviolet light that this produces is of no great danger to me. I shouldn't really stare my eyes into it, for the simple reason that my eyes being unable to detect it would leave leave the iris wide open and the retina exposed to a very bright light source. It's the only reason why it is dangerous. But with this, I can show how we have used UV to do certain things. And what I want to first show you is this. While the light is on, you can see this is a UV document marker. It's a pen that gives off almost clear ink when you write with it. That ink is a UV activated ink. So when UV light falls on it, it actually absorbs the UV light and re-emits blue light in its stead. So it's called UV fluorescence, and it basically means you can write secret messages on things that then only appear when the UV light is on. The second thing I'm going to show you with the lights off is this, some money. Yeah, very, very rich this week, my wages. But I want to show you that this is a real £5 note, that this contains some anti-forgery devices only visible when we switch on a UV light. And I switch all the room's lights off. This is the project room. It's one of the darkest environments that we have in the school. And when I do turn the light off, it will be pitch black in here. So now we're in this dark environment. Let me show you the UV tube. The UV tube is glowing with a small amount of purple light, but it is actually, in fact, very, very bright in ultraviolet. Now, if I bring my £5 note close at hand, you can see that glowing really clearly at the top there is the number 5. And all notes are impregnated with this UV ink. Is there anything on the back? No, not really. But you'll also find that your driving license, your passport, and all such things are activated by UV ink. And you can write secret messages. For example, if I was to use the UV pen, you can see that the UV pen itself, the nib of the UV pen, is glowing really strongly, and you can write some really cool secret messages on things, including like such as like your postcode on electrical devices, or you can go really to town and just like go for it and completely smother yourself in UV ink. You'll actually notice that my shirt is glowing, and that is because of phosphorescent chemicals in washing powder. And so what happens is a shirt that has been washed will actually glow in UV. So you might sometimes see these in nightclubs where they're used to make everyone's clothes glow really brightly. Oh, well, there we go. It's a schlur. Everybody loves a schlur. Oh, fabulous. Glorious. Now, some people like to sunbathe. They like to get outside, feel the sun's light on their body, and a little bit of light is totally natural. In fact, you need a bit of sunlight to unlock some of the vitamins within your skin. But a little bit too much light can also be a bad thing. You see, from the sun over there's also an amount of ultraviolet light that your eyes can't see that falls on your body. You certainly know about it. If you've got sufficiently fair skin and you expose yourself to too much sunlight, then what will happen is you'll get sunburn. And sunburn is the actual destruction of those top layer of cells in your skin. It can be really quite painful, quite unpleasant. And worse still, scientists have linked sunburn to skin cancer. That those UV rays can cause skin cancers in your skin. Places where your skin's cells have their DNA mutated by the ultraviolet light, and then they start to grow. And that's fairly terrible. So let us now talk about X-rays. So X-rays have a smaller wavelength still than ultraviolet and have more energy as a consequence. Now, a German scientist named Wilhelm Röntgen discovered that firing electrons across a small gap in a vacuum would produce a set of rays that our eyes could not see, and that those rays could penetrate through material. And what was eventually found through a lot of study was that on photographic film, such as this one here, that you could actually see your bones, because the X-rays could pass straight through the soft material of your body and not the hard material itself. Now, the study of X-rays moved very quickly on to France, where people like Pierre and Marie Curie worked extensively on X-rays, and we have one of the original books here, De la Lumière au Rayon X, which is basically a very, very old book from 1927 about how X-rays were very first used for medicine. And so therefore it has this really great use. In fact, it was Marie Curie, the famous scientist, the discoverer of the elements radium and polonium, who realised that X-rays could be used for diagnosing broken bones. In the First World War, Marie Curie realised that having X-ray tubes in ambulances would enable people that had been injured on the front lines to be diagnosed as to whether or not they needed limbs amputated. This X-ray tube is one of those original Marie Curie X-ray tubes from the First World War. And I myself have needed X-rays. This is an X-ray of my leg. You can see that I broke it really badly, and I've had to have pieces of metal screwed through the bone. The metal absorbs the X-rays to stop them from getting on the screen. In fact, the injury was so catastrophic, excuse my socks, you can see the scars here, down the side, down the front, around the other side. This injury was so catastrophic that had it not been fixed, I almost certainly would have died. And so the power of X-ray is basically preventing people from dying from broken bones. You see, now I'm right as rain, I barely limp at all. Now, those same X-rays can also cause some problems. You wouldn't necessarily want to be exposed to X-rays whilst pregnant, because it could harm the fetus inside. Also, extended exposure to those X-rays could cause cancer, and that is a life-threatening condition indeed. The highest energy wave in the electromagnetic spectrum is the gamma ray. Now, you really must consider these like high energy X-rays. There are major differences in the way that they're produced. Now, gamma rays are really dangerous. Gamma rays are things that are extremely cancer causing, but also we can use them in certain applications. This is a Geiger counter used for detecting radiation. See, gamma rays are classed as one of the main kinds of ionizing radiation might be harmful. Every time a gamma ray, most likely from a cosmic ray here on the second floor, hits this, then it causes this screen to deflect up by 1. Now, gamma rays have all sorts of uses. Not only are they very useful for sterilizing food and surgical instruments, they can also be used to detect where pipes are leaking. Another use is in medicine, where, as the main type of radiation used in radiotherapy, they can actually be used to kill cancer cells in your body. So there we have it, a walkthrough guide of the entire electromagnetic spectrum. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. You need to have an understanding of how each one is used. You also need to appreciate which of these are dangerous, and on top of that, how they are dangerous. And to reiterate, it is these 3 that are cancer causing. These 3 carry the most risk.